Hello, Data Standard community. I'm your host, Shana Weldon, and today we have a very exciting guest. We have Abhi Sharma, a Senior Business Director at Capital One. And today we're speaking about the ecosystem of data. Welcome to the show.
Thank you. Thank you, Shay.
Thank you so much for being here. And to start off, can you please just tell the audience a little bit about yourself?
My name is Abhi Sharma, and currently I work as a data and product leader at Capital One. My team is responsible for developing and managing data ecosystem for Capital One. In short, making sure that the data produced by our applications or third-party applications is available to human and machine consumers. And we want to make sure it's in an accurate, searchable, and easily consumable fashion. So it's actually well consumed. And then prior to Capital One, I worked in the airline industry, creating optimization models and also conducting data and statistical analysis.
So you have a pretty hefty background in data. How did you first become involved in data science, though?
My first foray in data or data ecosystem and data science started with this course that I took in grad school called data mining. And I vividly remember the first statement that a professor made was garbage in and garbage out. And interestingly, I think more than 50% of the course was around understanding data, the data quality and data preparation. Well, multiple examples resulting in failure because somebody was not doing it. So that's how I got started. It has become a common trend over my career where I've been part of creating models or doing analysis, which drove decisions, sometimes millions or hundreds of millions of dollars worth of revenue. And guess what? They heavily depended on underlying data, how good it was. Now, I think in my current role, focusing on data ecosystem really helps me because it helps both the data scientists and analysts who are going to make these hundreds of millions or even billions of dollars worth of revenue decisions.
So your professor, I'm stuck on the quote that you said, it's garbage in, garbage out?
That is correct. Yep.
What exactly did he mean by that?
So what garbage in and garbage out means, what you feed data, if it's garbage, then the output, what you get is garbage out. So you can create the best AI or a machine learning model or any model, but if the data is bad, there's no way you can get good results out of it.
Got it. I like it. I like that. So you're a senior business director at Capital One. So what exactly do you do?
So as I mentioned earlier, my team manages the data ecosystem for Capital One. So basically making sure the data produced by our applications is in an accurate or searchable and easily consumable fashion for the end user. So everything that comes between production of data and to consumption is well done. That's my role.
Okay. Regarding the ecosystem of data, how do you sustain data?
So, when you talk about sustained data, there are multiple components to it. So basically, if you understand what a good data ecosystem looks like, you start from the left side of how do you understand your data, make sure the quality is high, then transport the data because you have the producer side, store it, and then in the end, make it consumable. So this whole process together actually is where you actually make sure that the data ecosystem drives the sustainability of the data and drive the consumption in the end.
Wow. I know in the past 10 years, there's been a huge progression of data. What exactly, in your mind, I guess, what is the biggest progression of data in the past 10 years?
So let me start with three major components of data where we have leapfrogged. One is data capture. The other one is data storage. And the third one is data computation. If I go back in time, let's say 25 years ago, when I went to my role model's office, which is my dad's office, he used to work for the government of India. It started with the three things that I talked about. So capture. So the data was captured in a file, a physical file with sheets of paper inside. And they were written notes, they're typed notes. And then the second piece was storage. So there was this storage room, literally a storage room where you actually had shelf space. You will stack up these things, these files. And then retrieval or computation was based on this tags that were attached to the files, and most of them were alphabetical. So tomorrow, if I actually want to find everything about Shay on these files, I literally have to find the person tag with S and maybe find that. If not, then use your last name. But I'll miss out on every other file that had it. So this is how it was 25 years ago. And the last 10 years, it has changed a lot. So if you think about capture, the sensors have become really cheap and they're all connected to the internet. So if you just look around, you have phones, cameras, and even if you think about the non-digital sectors, the traditionally non-digital sectors, they are capturing data a lot because of the same progression. For example, cars have cameras and a bunch of sensors. Tesla has 8 cameras. My stationary bike has a bunch of way to capture my data, which is a Peloton. So it captures my heart rate, my workouts, everything about me. Second piece of this is storage. Storage has become really cheap and really fast. When I was a kid, we used to talk about megabytes and it was huge. Now we've gone to petabytes, which is huge. And soon I think we'll be talking about exabytes, zettabytes, and yottabytes, and they'll be really, really cheap. You and I can afford these kind of measurements of data. And the third piece is computation. It has become really, really powerful, really, really cheap over the time, following Moore's law. And if you bring it all together with the cloud infrastructure, it becomes so much more amazing because there's no setup cost. You use and pay as you go. And by the way, the cloud account, whichever service you use, has a bunch of utilities that help you actually create the solution. So in the end, if you bring it all together with the progression, data has become the most important asset, mode, currency for companies, any kind of company. And the future of companies is basically being able to leverage this asset as an asset versus as an add-on.
Thanks for that explanation. Yeah, it's truly remarkable to see data, I guess, change over time, and especially exponentially increase in the past 10 years. But how do you specifically collect, manage, and create models from data?
So I think if you think about what I was talking about, the ecosystem, I'll start with the analogy first. Consider a river that starts from a glacier. So it starts fairly pure and everything is perfect. And then it actually goes down different paths, meanders through all the different areas. It actually collects a bunch of issues. So it might have like sediments, it might have pollutants. And by the end of it, actually, once it meets the sea, you have fairly high pollution in that space. So if you think about models or consumption at the end of it, you want to start from the left side, where you actually want to make sure like from the glacier, it's really, really clean and it continues to be clean, because anything you can do at the top actually makes a lot more sense to drive through. So you start from the very high quality attributes of the data. So the data you're capturing typically you capture from your applications, you capture from your third-party applications. Once you capture them, make sure they're very high quality attributes about the data. Then make sure it's standardized. And I'm going to use standardized in a very liberal way, where it would account for making the data consumable, like making sure it's not just zero and ones or something, but it actually defines something, making sure it's standard across different sectors. So if you have like multiple cameras looking at me right now, all of them should say it's a nose, and they have the same definition of a nose or a face. And then making sure the quality is high. So in case one camera goes out or has some problem, it actually can figure out it's a bad one, so it will delete that data. And then once you have transformed it, you should know why or how you transformed it, because you wanted to standardize it. And then move it to data storage areas where it's easily accessible. So based on use case, you could have a low latency data source, which is basically talking about like milliseconds retrieval time, versus something which would take longer, a little bit longer, which is more like an analytical systems that we talk about. So all of this will drive you into good capture of data. And at the end of it, you actually have these models, which could be statistical models, regression models, or more complex machine learning models, which rely on the data being really clean. And that's how you make sure that these models and analysis systems are really well set up for success, and they drive like the value they would need to drive.
Okay. So using these models to ensure that the data is consumable at the end, what statistical analysis or models do you use when processing this data?
So when you're processing these data, the statistical analysis, and I'll start from the left side of consumption. So this will be more about your quality tools, your standardization tools, and every cloud service actually provides you different utilities that you can use in that space. So you could have like data models, which actually make sure your data is modeled correctly with the purpose it's consumable. So all of it is towards the purpose of consumption. And then once you actually move to the consumption side, you're talking about statistical analysis models like regression models, which drive dependent variables that actually drive a factor. Or you can have like these amazing machine learning models which sit on data and capture it and come up with valuable information at the end of it. And there you need the training data set, which actually needs to keep updated so that the machine learning model can evolve over time. So those are the models you'll actually end up using, not only for the processing, but also for consumption.
What is the biggest challenge that you face in your industry?
So I come from financial industry. The interesting thing is financial industries face almost the same challenges as any other company that were not born in the digital era. So if you look at the largest financial industry we have, which is the bank, it was formed in 1799. It's like a long time ago. Wow. But most of these industries heavily rely on data and have really reliable but old infrastructures. So this means that when I talk about all the progression we have made in the last 10 years, being able to use that progression from what the infrastructure right now is fairly big leap. And that's where the biggest challenge is. And it's not only for financial industries, it's any company you can think of. You can think about the retail giants, you can think about any other production companies that produce material or consumable. They actually have the same problem where they're using old infrastructure. And right now, to move to that new infrastructure, it's a huge investment of moving things and also moving away from really reliable infrastructure that actually they've been using for years and years or decades in some cases. And that's the biggest challenge I see that we face in this industry.
So we at the Data Standard are building a community of data thought leaders and data enthusiasts. We're open for collaboration and connection. And so what can we do for you specifically? What can our community do for you?
No, first of all, thanks a lot for having me here. There's a whole bunch of disruption happening in the data side. And what we hear is all around the usage side, which is machine learning, artificial intelligence. But I think the more important piece is the ground data, the data behind machine learning and artificial intelligence. On top of it, the challenges are very similar across different industry types. So because there's huge disruption happening in the area and the challenges are similar, I think it's important for us to share and collaborate across all data leaders and innovators. I would love to be part of that community that enables it. And I'm hoping the data standard community actually drives or enables it, which means if there are places where we can actually have virtual sessions, virtual speaker sessions, or in-person sessions when things allow us, or if you want to, I would love to be part of those and help collaborate, bring the whole data community to a different level. Because once we collaborate is when we actually drive real innovation across.
Right. Yeah, I totally connect with that. And we would love you to be a part of our community. And I really appreciate you being here as well. It was a pleasure speaking with you, and I appreciate you taking the time to speak with me today.
Oh, thank you, Shay. This was great for me too.
So you can find us at the Data Standard. Our website is www.datastandard.io. And this episode was also sponsored by Pandio, and they're innovating the tech space. And you can learn more about them at pandio.com. But again, Abhi, thank you so much.
Thank you, Shay.